Welcome to Intelligence Gateway.
Big Data Analytics. Introduction to Big Data Analytics. Big data analytics is the process of examining large and complex data sets to uncover hidden patterns, correlations, and insights that can inform decision-making and drive business value. It involves using advanced technologies and analytical techniques to process, analyze, and derive insights from vast amounts of structured and unstructured data. The goal of big data analytics is to help organizations make more informed decisions by uncovering insights and opportunities that may not be visible with traditional data analysis techniques. It can be applied in a wide range of industries and use cases, including marketing, finance, healthcare, logistics, and more. Big data analytics typically involves several stages, including data acquisition, data storage and management, data processing and analysis, and data visualization and reporting. It requires specialized skills in data science, statistics, machine learning, and other fields, as well as advanced technologies like Hadoop, Spark, and other big data processing tools. By leveraging big data analytics, organizations can gain a deeper understanding of their customers, optimize business processes, identify new market opportunities, and drive innovation and growth. Big data analytics tools and frameworks, Hadoop, Spark, etc. There are a variety of big data analytics tools and frameworks available to help organizations process, analyze, and derive insights from large and complex data sets. Here are some of the most popular ones. 1. Apache Hadoop. Hadoop is an open-source big data processing framework that allows organizations to store and process large amounts of structured and unstructured data across distributed computing clusters. It includes several key components, including the Hadoop Distributed File System, HDFS, and MapReduce, and is often used in conjunction with other big data tools like Apache Spark. 2. Apache Spark. Spark is an open-source big data processing engine that provides high-speed data processing capabilities and supports a wide range of data sources and formats. It includes a variety of libraries and APIs for machine learning, graph processing, and stream processing, and is often used in conjunction with Hadoop. 3. Apache Cassandra. Cassandra is a distributed NoSQL database designed for handling large volumes of data with high availability and scalability. It is often used in real-time applications and can handle a variety of data types. 4. Apache Hive. Hive is a data warehousing and SQL-like querying tool built on top of Hadoop. It allows organizations to query and analyze large datasets stored in Hadoop using a familiar SQL-like interface. 5. Tableau. Tableau is a data visualization and business intelligence tool that allows organizations to create interactive and visually appealing dashboards and reports. It integrates with a variety of data sources, including Hadoop and Spark. 6. Python and R. Python and R are popular programming languages for data science and analytics. They include a variety of libraries and tools for data manipulation, analysis, and visualization, and are often used in conjunction with big data processing frameworks like Hadoop and Spark. These tools and frameworks are just a few examples of the many options available for big data analytics. The choice of tool or framework will depend on the specific needs and requirements of the organization and the data being analyzed. Big data analytics use cases. Big data analytics has a wide range of use cases across industries, including 1. Fraud detection. Big data analytics can be used to detect and prevent fraud by analyzing large volumes of data in real time and identifying patterns and anomalies that may indicate fraudulent activity. 2. Customer analytics. Organizations can use big data analytics to gain insights into customer behavior and preferences, allowing them to tailor their products and services to better meet customer needs. 3. Predictive maintenance. Big data analytics can be used to monitor and analyze data from machines and equipment to predict when maintenance is needed, reducing downtime and increasing efficiency. 4. Healthcare analytics. Big data analytics can be used in healthcare to improve patient outcomes by analyzing patient data to identify patterns and trends and develop personalized treatment plans. 5. Supply chain optimization. Organizations can use big data analytics to optimize their supply chains by analyzing data from across the supply chain to identify inefficiencies and improve processes. 6. Financial analytics. Big data analytics can be used in finance to gain insights into market trends and identify opportunities for investment. 7. Social media analytics. Organizations can use big data analytics to monitor and analyze social media data to gain insights into customer sentiment, identify trends, and improve social media marketing campaigns. These are just a few examples of the many use cases for big data analytics. The potential applications of big data analytics are vast, and organizations in virtually every industry can benefit from leveraging big data to gain insights and drive better business outcomes.